Welcome back everyone. I've finished planning everything I need to plan for Unit 1 for computing. However, when I tried to upload some zip folders to the RonsTechHub website yesterday, it didn't work. So I'll figure that out at some point. Every single resource that I have here, I will be making it available completely for free for anyone, so teachers and students. So feel free to use it to do whatever you want. However, at the moment, I'm just going to try and get through the content first and then upload the files afterwards. So stay tuned. Let's go. So again, we're on Unit 1, Principles of Computer Science, and this is going to be for computational thinking. Bear with me. I won't be editing this video much, so you might hear a lot of ums and ahs and pauses. Just bear with me. Play it at 1.25 times the speed or 1.5 times the speed. That should help a bit. So again, we're back to unit information, and the four main categories of this unit are computational thinking. That's the first one there. Then we have standard methods and techniques used to develop algorithms. That's simply algorithm design. We have programming paradigms, and lastly, we have types of programming and markup languages. This lesson will cover computational thinking and its four subcategories, which are decomposition, pattern recognition, pattern generalization and abstraction, and algorithm design. When you guys do get the PowerPoint, you might notice a few blank pages here and there. I've used the blank pages to separate it for me because it just made it easier when making the PowerPoints, because some of them have like 100 slides. So what is computational thinking? A problem-solving approach used in computer science. It helps break down complex problems into manageable parts. Essential skill for programming and algorithm development. It is applicable to many fields beyond computing. So every single thing that we do, to be fair, we can use computational thinking to break down the steps. For example, waking up and getting ready for school. Typically, you wake up, you turn your alarm off, you go have a shower, you brush your teeth, you have your breakfast. Some people brush their teeth afterwards, but again, these are the steps that we have to follow to get to the end goal. It doesn't really matter how you get there, simply the steps we need to get there. So decomposition, identifying and describing problems and processes, breaking down problems and processes into distinct steps, describing problems and processes as a set of structured steps. So all of these mean exactly the same thing. I'm just trying to describe it so that everyone who's reading this or listening to this can understand exactly what it is. So you also communicate the key features of the problems and processes to others. So you simply tell, state, write down, describe, break down, identify, whatever it is, the steps that you need to follow to get to your end goal. Again, if you're trying to get to school, you wake up, you shower, you brush your teeth, you eat breakfast, you put your clothes on, you leave the house, you take the bus, you take the train, whatever it is, you break the steps down, and that's how you get to your decomposition. The example I have here is how to make jerk chicken. It was a bit of a silly thing, but I just wanted to create it again just to explain or show the steps you have to follow. So obviously you work, you get paid, you buy the chicken, you clean the meat, sorry if you're vegetarian, you season the meat, you cook the meat, you eat the food, you sleep, and you repeat the process again and again and again. So these are the steps you need to follow for one really random silly task, but again, it's all about the steps you have to follow. Here's another example. So this one, to get name, save to file. So this is using Python 3, I believe. Every single example I have in here, I do believe I have a Python 3 code that shows you how to do that exact thing. So when you manage to download all the resources I've given you, there should be a folder called code as well, and you should be able to get everything you need from there. So this is what we would do to solve this problem here. So we would get name, and we do this by prompting the user to enter their name, store the entered name in a variable. We create a file. So we create a new text file, specify the name, example name.txt, open the file in a write mode. In some languages you can open in read mode, write mode, append mode. I don't remember all the modes, but those are some of the things that we can do. Write name to file, write the stored name to the open file, close the file, and save the changes. This is typically how we would break these steps down. And here is the example in Python 3. I believe I have code for this, so check the code folder, please. Next, we have pattern recognition. So what is pattern recognition? Identifying common elements or features in problems or systems, identifying and interpreting common differences between processes or problems, identifying individual elements within problems, or describing patterns that have been identified, making prediction based on identified patterns. Again, all means exactly the same thing, trying to give you different definitions to try and explain exactly what this is. Why do we do pattern recognition? Helps us spot trends and make predictions, enables us to generalize knowledge and apply it to new situations. Example, recognizing patterns in a data set. Then you don't need to go look through the entire data set again and again and again. If you've identified something, you can say, okay, when you have a new data set that's from a similar company or a similar thing, you can say, okay, last 10, 15, 20 times I did this, I noticed this pattern. So let's look at that first to see if it's the same. Identifying recurring themes in a story. So the pattern recognition example that we can use is the FIFA menu from the FIFA games. The pattern recognition example I have here is a pause menu. The FIFA games are the same game every single year. I know people who like FIFA and they say, no, it's not, it's different. It's the same game. Stop it. They do not need to recreate the game start menu every single time. They take what they have and make small tweaks. For example, the FIFA start menu might have been the same code for years because it barely changes. It's going to be start, career, pause, online, whatever those menus and options are. Next, we have pattern generalization and abstraction. What this is, what is abstraction, identifying the essential features of a problem and representing them in a simplified form, filtering out unnecessary details to focus on essential elements. Simply put, if you're looking at a problem or trying to solve something, you don't need every single piece of detail surrounding it. You only focus on the things that you are interested in. I think I give a good example of Google Maps at the end of this, so let's try and get there. So what is abstraction? Again, representing parts of a problem or system in general terms by identifying variables, constants, key processes, repeated processes, inputs, and outputs. Why is abstraction important? Simpler code, easier to read, write, and understand. Reusability. You can use the same code in different places. Problem solving. It helps break down big problems into smaller ones. Teamwork. Different people can work on different parts of a project. And the reason you can do this is not every single member of every single team is going to want to know how to make a start menu. Some people on the FIFA making team are going to do characters. Some people are going to do animation. Some people are going to do sound. And the sound people don't really need to know what the others are doing. They simply need to do their bit. And then when it comes to the very end, we can put everything together. Abstraction example. Imagine you are driving a car. You don't need to know exactly how the engine works or how the brakes stop the car. You simply need to use them, turn the car on, start it, brake when you need to. You just need to know how to use the steering wheel, gas pedal, and brake pedal. This is abstraction in action. This is obviously a real world example. Another abstraction example, Google Maps. We do not need to know all the streets we go past. We only need to know the directions to the location we're trying to get to. So imagine I'm driving from Lewisham to Brixton or Peckham, right? I don't need to know all those tiny side roads going all the way down. I simply need to know the speed limit, the roads I need to turn on. So abstraction also, again, is a way to compartmentalize. So we have our variables, we have constants, we have key processes, repeated processes, inputs and outputs. Next, we have algorithm design. What is algorithm design? Describing a step-by-step strategy to solve a problem. Why is algorithm design important? Speed. Good algorithms can make computers work faster. Efficiency. They can save resources like memory and energy. Correctness. They ensure the computer does the right thing every time. Problem solving. They help us break down big problems into smaller ones. So the two main types of algorithm designs that we have and we know we will be using are flowcharts and pseudocode. So flowcharts, I think this is the end of this PowerPoint, but I will go back and explain this at some point again. So flowcharts are a pictorial. So it's essentially a picture, a diagram explaining the logic or flow of the thing you're trying to do. Whereas pseudocode is a textual description. So again, you just have text trying to show exactly what you're trying to solve. Flowchart pictures, pseudocode text. So next time we're going to be looking at standard methods and techniques used to develop algorithms. Stay tuned.